Thank you very much. I'm Stefano Tivi, working for the Joint Research Center, Big Data Lead Scientist, and I will cover this subject, the subject particular part, you know. So why in more popular? Because in the present approach, in order to solve challenges, and in particular, it is said how to extract actionable intelligence for the huge collected and generated daily, how to make our smart, important in order and develop a more sustainable society. And final, indeed, this is important if we want to up between the different, you know, and the different competencies that characterize our technology. Yes, indeed. I mean, as Alessandro, technology is playing a quite important and several computation are analytics, computing science, and architecture, math science, or extended. And one very popular pattern is IoT. In particular, here I am explaining, try to, you know, raise the attention to a second generation of IoT, of Internet of Things. So while the first generation connected billions of different devices to internet, the next generation, the second generation, promises to make them smart, so to generate that actionable intelligence that is needed by our society. And as you can see here, the process implemented by IoT 2.0 is the typical process where you collect information from sensors, you move it where you can run artificial intelligence data learning models, you extract insights, and then you apply and you know act back on the observed phenomena and entity. So this is IoT is today. And well, the other important pattern is digital twin. It was mentioned several times this morning. One of popular definition of digital twin. Alessandro already explained it, but is maybe less familiar. It is the concept of digital thread. Digital thread is the process which is needed in order to integrate all the digital components for enabling the generation of a digital twin. Here in the cartoon, I try to capture digital thread. And in order to implement this, you must take care of the entire life cycle as well as of its information and reference models, and of course security as well. So a instance of a digital thread, the outcome of digital twins are very popular or are going sectors of our society, and have listened to Kumar presenting how you know new and interesting developments in sectors such as here we have BIM or Industry 4.0, but also urban areas such as city twins, smart cities, healthcare, virtual physiological human, personalized medicine or physiological twins, energy, transports, and several others. Well, in terms of how to, to apply to the Earth or to our globe, here there are two important to adapt the digital twin paradigm and processes to the natural and societal phenomena and processes. One can be seen as a scalability issue, how to scale up from local to global, and in particular, how to compose existing digital twins. Also discuss a recently published of Digital Earth, which introduce the science. Here you have the reference, of course. I mean, composition. This is a quite important topic because clearly we have a next future where several digital twins of Earth entities, phenomena, and processes may be, connected and composing what can be seen as an ecosystem of digital twins. An ecosystem which is very dynamic, a highly evolvable, ecosystem due to many different challenges, policy, economy, the social, scientific, and the technological realms, domains. And therefore, this ecosystem has to address important challenges such as viability, how to maintain a common value, the ecosystem common value versus the single digital tool or enterprise common. And this is a possible pattern, a possible good approach to develop a different level of, let's say, governance. So not to design a system of systems, so a system of digital twins, which is invariant, but on the other side, I mean, to leave it as flexible and evolvable as possible, and to develop a meta system defining the real environment, the real invariance of these ecosystems, such as invariant laws, principles, common values, technological traits, formal rules, etc., and apply these invariants, principles, and rules through a cybernetic mechanism, which is implemented through via communication and control software. And just a couple of final slides dealing with initiatives launched exactly to digital twins of the Earth, and a high, a high level architectural design. Destination Earth, as you can see here, we have 3 different tiers. The computing and data infrastructures and platforms, including HPC, the ecosystem of the so-called core platform, and then on the top of this we have digital twin and the many applications that different kinds of users should provide or are encouraged to develop. And here the intelligent services are, of course, the generation and use digital twin, also the sharing of the components that are in other words. This effort must be also seen as the enabling core of an and geospatial data ecosystem, contributing to a larger development, which is called Green Deal data space, in order to address, as I said, the changes affecting our society. On the right side, some principles are very well known. Some of them are very well known, such as modularity, and others maybe are less known, such as to preserve. It is important not to push too much the or federation, because we have the digital diversity as well in order to make resilient, and then viability and component autonomy. And that's all. I stop here.